So basically, in this question, we have Kiko, who tosses 1 penny, and Ephraim, who tosses 2 pennies. I want to know what is the probability that Ephraim gets the same number of heads that Kiko gets. So basically, like, this is like a probability question. And we remember on the AMC 8, like, you always know that probability is equal to like number of success divided by the number of possible, right? So remember, like, this is like the golden formula for probability. Like, there are other ways to calculate probability, but those, like, and like you could use those ways too. I guess I can like talk about those afterwards, but like just like basically the only formula you need to know is like probability is the number of success divided by number of possible. So a lot of times it's a good idea to think of probability as kind of like two counting problems. One counting problem answers how many success, another counting problem answers how many possible. So to find the number of success, notice that like Kiko, if he tosses that 1 penny, he can either get heads or tails, right? So let's suppose like Kiko gets like heads. So let's see, gets heads. Then Ephraim has to get 1 head, right? The question said, what is the probability that Ephraim gets the same number of heads that Kiko gets? So Ephraim tosses it 2 times. So in order for him to get exactly 1 head, Ephraim can get like first flip heads, then tails, or he can flip tails and heads. So in total, this gives like 2 possible ways, right? He can flip heads, tails, or he can flip tails, heads. The second case is when Kiko flips tails, then Ephraim, in order for him to get the same number of heads as Kiko, he needs to like toss 2 tails. Like, he can't get any heads. And in this case, there's only 1 possibility. So adding 2 and 1, that gives 3. So 3 represents the number of success. So there are 3 ways for this to happen. To find the number of possible, Kiko tosses the penny 1 time, so it can land either heads or tails. So that's 2 possibilities. And then times, and then Ephraim tosses it 2 times, and each time it can be heads or tails. So times 2 times 2. So the second 2 times 2 represents the Ephraim's 2 tosses, and the first times 2 represents Kiko's tosses. So 2 times 2 times 2, that gives 8. So that represents the number of possible. So the probability would just be 3 divided by 8, which is choice B. And that's the right answer. So I guess like another way like to calculate probability is like a lot of times at least in AMC 8 problems, this formula is like enough. Like this formula is like enough to basically solve like in the most of the probability problems. But like another way you can look at this question is like you can kind of like directly multiply probabilities. A lot of times, like maybe this way might be like faster in some cases. Like the idea is like if Kiko, you can kind of like do casework again, right? So Kiko tosses the penny. So there's a 1/2 chance that Kiko tosses heads, right? So this is 1/2 chance that Kiko tosses heads. That means like we need Ephraim to toss either heads, tails, or tails, heads. So Ephraim tosses heads, tails with probability 1/2 times 1/2, right? There's a 1/2 chance he tosses 1 head, then another half probability he tosses 1 tail. That gives 1/4. The probability he flips tails, heads is going to be 1/2 chance he flips tails first times 1/2 chance he flips heads first. That gives 1/4. So the total probability he gets exactly 1 head is 1/4 plus 1/4. But we also have like the case when like Kiko tosses tails. So 1/2 probability that Kiko tosses tails. And in that case, we need Ephraim to toss 2 tails, because we need him to have 0 heads. So we do 1/2 times 1/2. This first 1/2 represents like Ephraim first tail, and this represents the second tail. So we can directly calculate it like this too. 1/4 plus 1/4 is 1/2. 1/2 times 1/2 is 1/4. And then here, this 1/2 times 1/2 is 1/4. 1/2 times 1/4 gives 1/8. So we do 1/4 plus 1/8, right? 1/4 plus 1/8. And if you add them, you also get 3/8. So that's like another way to kind of do the problem. It's kind of like doing the same thing basically, but like I guess it looks kind of different. Like it doesn't look the same. So those are like 2 different like ways you can calculate probability. Like this way is like useful when you have like independent events. Like sometimes this way might actually be easier, but usually this formula, number of success divided by number of possible, is usually like more straightforward to use, since we can easily identify, what is the success. Well, the success represents like the question that the problem is asking, and the possible outcomes represents like what things you can get. So I think it's like a good idea to think of probability as like kind of two separate counting problems. Yeah, so that's how you do that problem.